Good evening, everybody. Good evening, my follower. This evening I want to teach you people on how to do some calculation in instrumentation, and there are some formula I want you people, my follower, my people to know. So major formula we use in our calculation, because in our instrument we do some rough calculation. We have some standard values. At times we do compare the standard values for our calculation. So like what you can see is formula for calculation, your calculated value to simulate your equivalent value. So as you can see, this is our percentage 0 to 25, 100%. We have our millimeter, 4 to 20 millimeter. We also have pressure. All these values you are seeing here, they are all standard value. These are standard value we use. What the standard value simply means is that every value that is given in our transmitter, in our process range, they are all range from 0 to any figure. Like you can see here, this is our gauge. It's from 0 psi or 0 bar to 7,200 psi and 500 bar. This is the range of the transmitter. Even this one you can see, this is our digital transmitter. You can see it. The range here there's a range. The range is from 0 to 11,856 millimeter water. You can see the range here. This is the range of the transmitter. This is the range. This one you are seeing here. From 0, look at it very well. This range here is 0 to 1,856 points. This is your millimeter water. This is your range. So that range you are seeing, you need to do some rough calculation in order for you to simulate it. In order for you to use that range to test your sensor. The reason for that range is for us to test our sensor. What you are seeing under this transmitter now is, for here in this particular area, is our sensor. This is manifold, 5-way manifold. It's attached to this transmitter. This place you are seeing here is a sensor. So when we simulate our transmitter, as you can see in our transmitter, this is high side. This is where you connect your tubing to simulate it, and this is our low side. You connect from here. From this our drook, we need to pressurize our drook. You press our drook, you pressurize it, as you can see it. This is, you push it. As you push it, the pressure from here you use to simulate this transmitter. Why? In our gauges we use this comparator. We use this comparator to simulate. As you can see from my calculation, I will still take you back to that comparator and the gauge and everything you are seeing there. But I want you to know more about our calculation. As you can see from my formula here, general formula for calculating your span. Your span is what you use to calculate your 0 to 25%. As you can see, 0 to 25% is your span. 4 to is your span you use to compare. Now this range you are seeing, we will still come to the calculation. As you can see, this range you are seeing here, 0 to 7,200 bar. If I want to use that particular value now to test my sensor, because every sensor have range. As you can see from that transmitter, the transmitter have range. Every sensor have range. So as you can see, this range here, this is the range. You can see here, every other have range. And for you to know what to simulate, you need to apply your formula. You cannot just go and simulate anyhow. Most people do just say they will just share it 4% and divide by 4. But divide by 4, they don't really know the formula that is really applicable to this calculation. So this is our formula we use in calculating our calculated the value we need to simulate, because you cannot just simulate anything you like. Like you can see, this is our calculated value, 100%. This is your percentage, which is here from year to year, your percentage times span. You see, this is your span. This is your span times span plus your low value, low low range value. This is your lower range value. For all our parameters, we have upper range, which is from 0 is the lower range, right? Like here, 0 is your upper range. This is your lower range is 0, while your upper range is 7,200 or 5,000. Or 7,200 is your PSI value, while 5,000 is your bar. So from here, this is our formula we use. The span, you can see, formula says percentage calculation is equals to value is equals to 100 times span plus low range value. So I would have from here our span is equals to upper range value minus lower range value. Upper range span is equals to upper range value minus lower range value. This is the formula you use for your calculation, your flow, your temperature, your pressure. But we'll still talk about the level. Level is different. So let me come now to our calculation of pressure. The range of the gauge is range 0 to 500 bar or 0 to 7,200 bar. This is what is in our range of our transmitter here. 0 to. So now, for me to simulate, the reason why I'm simulating, let me tell you a sheet. This is a sheet. This is a mechanical completion sheet. In this mechanical completion sheet, you need to fill in your 0, as you are seeing, your input of 25%. If you input 25% of that value, what is your sensor showing us? The control room will be seeing it. There's no way that is viewing it. You're not seeing 25% of your mechanical completion sheet. This is a mechanical completion record. This is a sheet. To see it very well, this is a sheet. So this part of the sheet, those values will be you input them into it. You input them. So let me do fast so as you can see, this is the range. For me to have my 0% to put on this, for me to have my 0%, okay. Awesome. For me to have my 25%, 0%, 25%, 50%, 75%, 100%, I need to use my calculator. This is the formula, upper range as it was there. This is the range of the transmitter. This is 7,200 is your upper range, while the lower range is 0. So for me to get the span, because the span you use to do your calculation, you minus your upper range, you still have 7,200. So at 0%, what do you have? 0% times 100 times 7,200, you have 0. 25% over 100 times 7,200, you have 1,800. So all this value, the 25% now is 1,850. In my pressure, if I want to have my 25%, I want to show it at the control room, I will pump in from here now. You can see in this our digital gauge. From this our comparator, I will press that particular 1,800. That one will be my 25% here. If I press it, let me just do it. You can see 25%. Okay, this our gauge is not okay. So don't worry about that. You know it later. You have seen before I'm doing it. So from here you can see this digital gauge. If I want to pump 25% now, 25% is what? 1,800. From here you can see it. 25% is 1,800. So this 25% that is 1,800 is that what it simply implies is that you use your pressure drook or your comparator to simulate means to pressurize your sensor to give you that 1,800. And at that 1,800, your control room will be seeing 25%. Control room will be seeing 25%. Control room will also be seeing this value here, which is 1800 psi. Also applicable to 50%. This is 50%. 50%, you come after your calculation, you get 3600 psi. The psi is what you really need to pressurize your sensor. So from here, I will press. From as you can see, this one is increasing. So I do it, press it. You see the pressure will be. As you can see, that's how the pressure will increase to that particular value. That's how the pressure will increase. So that's how you also do in your 75%. 75% of 100, you get 5,400. You pressurize your sensor. Control room will be telling you this is what is in the control room, 25%. So control room value. So that's how you will do this. Our tubulation input value, 25% at 0 psi. Because this 4 milliampere you are seeing is a standard value. 25% is a standard value, but right here is a calculated value. We calculate this value from the range that was given to us. Remember the range. You get 8 AM, 8 milliamps. 50% here is also 3600 psi from our calculated value. You saw it there. This is also a standard value of 12 milliamps. 12 milliamps, which is 50%. So definitely, what here simply means is that if you simulate in this transmitter now, if you simulate 12 milliamps, what control room will be seeing is 3600 psi and 50%. So 75% is 5400 psi at 16 amp. If you simulate from feed 16 amp control room on this transmitter, you'll be seeing 5400, because that is the 0 to 7200 is the range of that gauge of the pressure transmitter. As you can see here, is 100%, 7200, 2020 milliamps. So that is how it is. This calculation is easy for you to learn. Take it every time, make everything very simple. The formula is there for you. Take it and go and calculate it. So there's also another calculation I want you to my people to know. There's another calculation. At times people do make mistake when they have range of minus 45 psi to 8400 psi. People do make mistake. They will just go and be calculating divided by 4, divided by 4, divided by 4. You can only divide by 4, divide by 4 when it is from 0 to 8400. If it's from 0 to 8400, okay, divide by 4. You have divide by 4 again, divide by 4. But that divide by 4 is not. You need to apply the right formula to do your calculation. So now, because this one is very critical, it's a crucial something I want my people to know. Minus 45 psi to 8400 psi. Upper range here now is upper range value is 8400 psi. While the lower range value LRV is minus 45 psi. So your span, since your span is upper range by lower range, is 8400 minus 45, which is what? 8445 psi. You know, some people do make serious mistake. I've seen many engineers. Why do they make that mistake? Because they didn't follow the right formula. You need to follow the formula. Without following this formula, you will have your calculation wrong, and everything you are simulating to your transmitter will be wrong. So from here, we see our calculated formula is percentage over 100 times span plus lower range value. Our input here, which is 0% here, 0% over 100 times 8400 minus 45 psi kilowatt, Q minus 45 psi. So at 0 you have minus 45 psi. At 25%, your calculation will have what? 2066.25, or we'll do it to 2066 psi. At 50%, you have 50 over 100 times the upper range, 8445 minus 45. After your calculation, you have what? 4178 psi. 75%, you have 7000. At the same thing, you have 6000 something. So follow this calculation. Follow it, and the end you have your. You know how to do this calculation. Just follow it, and this is my tubular value. After I tubulated it, after the calculation, you tubulate it. calculate it at 14 at 0 minus 4 milliamps. 25%, 2666. So that is that. See, look at it. Look at it. At 25%, 2 year, 8 milliamps. So when you simulate 8 milliamps on this transmitter, you have 2665. But when you pressurize your transmitter with 2066 psi, you will have 8 milliamps in your 8 milliamps, and your DCS you have 25%. So just studying it and you know it more. Take your time to look at the calculation. Thank you. So these are the tools we use for the calibration. These are our pressure gauge. This value here, this is your value here. This value, all this value you are seeing here, is this your droop we use to pressurize it. Push it, we push it, we pressurize the transmitter. From here, we use our